Question is looking at a rectangular sheet of metal which measures 50 by 40 centimeters, and then congruent squares of side length x centimeters are cut out from each of the corners and not used further. The sheet is then folded up to make a tray of depth x centimeters, and you're asked to find the value of x for which the volume tray is a maximum. So the first thing when tackling any of these types of questions is to draw what you've got. So initially there's a 50 by 40 rectangle. Then we're cutting out congruent squares, which means that all the squares are of the same size here from each of the corners that have a side length of x. So each of these is x. I'm going to just draw little lines to show they're all the same length. Now, it says that these are cut out and not used further, so what we're left with is a shape that looks like the net of a rectangular prism, and we know this is x and this is x, and these side lengths here would now be 50 take away 2x, because we've taken off x from this side, and 40 minus 2x, because we've taken off two lots of x from that length. When it's folded up, you're going to get a nice rectangular prism tray, open lid, and height there of x, 40 minus 2x, and 50 minus 2x. So the question is asking us what is the x value for when the volume is a maximum. So we have to find the volume of this shape, which would be 50 minus 2x times 40 minus 2x times x, which is just length times width times height, which would come out to 2000 x minus 180 x squared plus 4x cubed. I might write these in descending power orders. So minus 180 x squared plus 2000 x. So that's our velocity formula. Now we want to find when this is a maximum. So if we were to graph this, this would be a cubic. The maximum would be a stationary point. And stationary points occur when the derivative is equal to 0. So let's derive our velocity formula, and would get 12x squared minus 360x plus 2000. And we have to solve for when this equals to 0. And you're going to get x is approximately equal to 7.36 or 22 point something. Now, when we look back at the question, now I've used my calculator to find these two x values, just solve equal to x. I've got two answers. If I know that this side length here is 40, then the x values from which I've cut off here and here cannot be bigger than 20, because then that would overlap, and practically and physically this box could not exist. So 22 I can rule out as an answer because it's outside the domain implied by this physical box. So my final answer would be the 7.36.